in this video, let's look at what we have here. We have to prove that dy over dx of exponential power x is equal to exponential power x. Prove that dy dx of exponential power x is equal to exponential power x. How are we going to do this? It's very simple. Now, many people out there know that dy over dx of e of dy dx of exponential power x is the same thing as what exponential power x. And if you ask them, why did you tell us that exponential power x, the derivative of exponential power x is equal to exponential power x itself? If you ask them, they will be like, we don't know, but we know that dy dx of exponential power x is the same thing as what exponential power x, which means they are just saying it without a proof. But in this video, I'm going to show you how to differentiate exponential power x and why the derivative of exponential power x is still equal to exponential power x. Hope you get it. Now let's get started. This is what we need to know. We can do this by the understanding of the Maclaurin series. You get Maclaurin series. So I can now say this. Let's just say this is a solution to this problem. So I can say using the Maclaurin series. Now, if we apply the Maclaurin series, we are going to look at how we can solve this. Now, before you can apply this series, you need to know what the series is all about. Hope you get it. So we know that Maclaurin series f of x is equal to what? F of 0 plus x multiplied f prime of 0 plus x squared multiplied f prime of 0 all over 2 factorial plus x cubed multiplied f prime of 0 all over 3 factorial, and the series continues. Now this is how Maclaurin series looks like. Now you need to know that f prime means the derivative of the function once, and f prime means the derivative of that function twice. F prime thrice, like that, that's what it means. Now, before we can do that, we need to bring out our exponential for x also. We know that our exponential for x is equal to what? 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x power 4 over 4 factorial. Now, this is the power series or the Maclaurin series of exponential power x. Remember, this is not e power x. If you say e power x, you are speaking like somebody that's not you are not in the mathematical terms. You are not using the terms. So the right word for this is exponential power x and not e power x. Hope you get it. Now, this is the power series for exponential power x. And remember, the series continues. Now, remember, we are asked to state, we have to prove that the y dx of this is still equal to this same function. Now, if we should differentiate, now this is what we are going to do. Remember, let's think that exponential x by x is equal to, now if you differentiate 1, that is a constant. Remember that the derivative of a constant is equal to what? 0. So if you differentiate 1, you are going to have what? 0 plus. Now if you differentiate x, you are going to have 1 plus. Now if you differentiate x squared, what are you going to have? You are going to have 2x. Remember, 2 factorial means 2 times 1. 2 factorial is equal to what? 2 times 1, which is equal to what? 2. So 2 factorial here is what? 2 plus. If you differentiate x power 3, you are going to have 3x squared all over 3 factorial. Now 3 factorial means 3 times 2 times 1, which is what? 6. Because 3 times 3 is 6 and 6 times 1 is what? 6. So 3 factorial here will be what? 6. Now plus x power 4, if you differentiate x power 4, we're going to have 4x power 3 all over what? 4 factorial. Now remember that 4 factorial is equal to what? 4 times 3 times 2 times 1, which is equal to what? 24. Because 4 times 3 is 12, and 12 times 2 is 24 times 1 is the same thing as 24. So we can replace this by what? 24. Now let's proceed further. We have that exponential power x is equal to 0 out. So what we are left with there is what? 1 plus. Now 2 and 2 cancel out because it's common on both the numerator and denominator. What is left there is what? X plus. Now we have 3x squared over 6. 3 can go into 6 because if you have 3 over 6, 3 will go into 3 one time. 3 will go into 6 two times. It's 1 over 2. Now this 1 up now, the 1 at the numerator here No, the one will multiply the x squared here because we are dealing with this now. The one will multiply the x squared. So we are going to have x squared over, instead of 6, because there is what? 2. Because 3 goes into 6 two times. Now we are left with the next one, which is what? 4. 4 can go into 24 how many times? Now let's look at what we have here. 4 can go, let's say, 4 divided by 24. Now 4 will go here. 1. 4 will go into 24 6 times. You get it? Because 4 plus 4 will give us 8, plus 4 will give us 12, plus 4 will give us 16, plus 4 will give us 20, and plus 4 will give us 24. So it means 4 will go into 24 how many times? 6 times. Now we are going to replace that by what? Remember, the 4 will cancel out. Because 4 goes into 24. 1 over 6. You can see 1 over 6. So the 1 will multiply the s cube. We're going to have x over 3 all over 24. Now we reduce to 6. Because 4 has gone into the 24 and left it was 6. Remember, the series continues. Now, this is what I want you to note. This thing is the same thing as exponential or x is equal to 1 plus x squared all over. Now, 2 is the same thing as what? 2 factorial. 2 is the same thing as 2 factorial because 2 is the same thing as 2 times 1. Remember, I said 2 factorial is equal to what? 2 times 1, which is equal to what? 2. So 2 is equal to 2 factorial plus x power 3 all over. Now, let's check at this 6. This 6 is the same thing as what? 3 factorial. Because 3 factorial is equal to what? 6. So you can see that if we differentiate exponential over x, when we differentiate the function, we are still coming back to have the same thing. Let's look at 1. 1 comes down. X comes down. S square over 2 factorial, x square over 2 factorial, s cube over 3 factorial, s cube over 3 factorial. You can see the series continues. You can see, and that is how to prove that the derivative of exponential or x is the same thing as the function itself. You get it? So if you find this very interesting, do not hesitate. Make sure you like this video, comment, and share this video for greater understanding. I'll see you in my next class. Bye.